Okay, so let us start. And mm, okay, fine, right? So we'll discuss this question number 19. An open organ pipe of length L is sounded together with another organ pipe of length. So there is a open organ pipe, both side is open organ pipe. Okay, its length is L, sounded together with another organ pipe whose length is L plus X. Another organ pipe is L plus X, but they have not mentioned whether that another organ pipe is open or closed. So what should we do? With another organ pipe, should we take it open or close? We do not know, right? Okay, in their fundamental tones. So we do not know this organ pipe, but they are saying that open organ pipe of length is sounded together with another organ pipe alpha. Here X is very small. Okay, so together they are sounded. The beat frequency heard will be. Let us consider it's also open. Let us consider this is also open. So beat frequency will be, so frequency formula for open organ pipe is 2n minus 1 odd multiple into V by 4L. No, closed, that is, this is open means n into V by 2L. N into V by 2L, right? This is the formula, correct, right? This formula is for open organ pipe, you know that, right? Okay, assume that it is also open organ. Only thing is that length is little bit is different. This is also organ pipe, length is little bit different. So X is nothing but change of length. X is nothing but change of length. Question is what? Question is beat frequency will be. They are asking beat frequency. What will be beat frequency? So what is beat frequency? Beat frequency is the difference of difference of the frequency. So how do you calculate that? Yes, so can we just, and they are fundamental. Fundamental means n is 1. So use n equal to 1 here. So let us say that this is f1, and for this you write f2 v by 2 L plus x. Now tell me what will be the difference and which is larger? Which one is larger? Tell me. Which is larger? F1 or F2? F1 is larger. So F1 minus F2 you do calculate beat. F1 minus F2. Solve it. So V by 2L minus V by 2L plus X. So V by 2L minus V by, let us take 2L common here, so it will become 1 plus X by L. V by 2L can be taken as common. This will become 1 minus 1 by this factor can be written as 1 plus X by L power minus 1. And using binomial expansion, you expand this because X is very smaller than L. Binomial expansion you apply now. So V by 2L 1 minus, apply this, so 1, this will become minus X by L. Show what will you get? Beat frequency will be V by 2L, 1 will get cancelled, X by L will come. So Vx by 2L square. Let us check the answer option. Vx by 2L square. Option C is matching. Option C is matching. Correct? Yes. Now, is there any other way to solve this question? Is there any other way to solve this problem? What do you think? But see, there can be another approach of differentiation. We can apply differentiation in f. This is the formula for frequency, right? Frequency is v by 2l. Here l is changing, and that also l is changing by a very small amount. So you can differentiate f with respect to l. So if I differentiate df by dl, then what will get? Because v by 2 is a constant, will come out. So you have to differentiate 1 by l with respect to l. What will you get? 1 by l differentiation is what? Yes, tell me. What is differentiation of 1 by x with respect to x? You should know this. Yes, tell me. Hmm. Satresh, Kavin, minus 1 by x square, right? So when you differentiate this 1 by l with l, so minus 1 by l square. Okay, right. So now from here df I can write as minus, I can take common, v by 2l square into x. Anyway, what is beat frequency? Beat frequency is nothing but magnitude of this df. Magnitude means difference of this. So difference, when you take magnitude, you got the answer Vx by 2L square. This is another shortcut to solve this. Yes? Clear? Are you clear about this? Okay, so always there will be some shortcut in some question. You can save your time. Let us go to the next. Question number 27. There is a set of 4 tuning fork, one with the lowest frequency uh, at this 550 hertz. By using any two tuning fork at a time, with frequency that can be produced are this. The possible frequency of the three forks are. What they are saying, that there are 4 tuning forks, okay, and one with the lowest frequency is 550 hertz. So let us say this is first tuning fork, second tuning fork, third tuning fork, fourth tuning fork. So first has a frequency of 550 hertz, lowest frequency. This is f1, but we do not know f2, f3, f4. We do not have any idea about that. We have to calculate that. And they are saying that the beat frequency by using any two tuning forks at a time. So you can choose any two and find the difference of frequency, that is beat frequency. Beat frequency that can be produced are, beat frequencies are given here. 1, 2, 3, 5, 7 and 8 hertz. The possible frequencies of other three. What are the possible frequencies of f2, f3, f4? Okay, think about it. f2, f3, f4. Possible means differences. So differences must be 1, 2, 3, 5, 7, 8 differences. And by using any two tuning fork, they have not said which tuning fork, but any two tuning fork. So you can use 1, 2, 1, 3, 1, 4. You can use 2, 2, 3. Okay, let us check how many combinations are possible. Okay, first you think like this. Suppose if I choose the first tuning fork, I can make group with second, first I can make group with third, first I can make group with fourth. These are possible combination. Okay, so and first is 550 hertz. First is 550 hertz. Okay, let us check group. What are the groups possible? Then second we can group with third, second we can group with fourth, right? Then we can group third with fourth, correct? Is there any other group possible? No, I think these are the possible groups, right? Yes. Pair you have to make 1 2 1 3 1 4 2 3 2. Again you cannot take 2 2. Same you cannot take, two different are there. So 2 3 2 4 you have to take, 3 4 you have to take. Okay, that's all. Now what are the possibilities if you consider? Hmm, difference of frequencies. Yes, yes, Kevin. Yeah, you can take that definitely. Number you can calculate, but ultimately you have to take the differences. And like for example, here I have to take f1 minus f2 or f2 minus f1. Here I have to take f1 minus f3 or f3 minus s1. So we need to write all that combination, correct? Combination you can use NC2 because you are making a pair. But by making that number, you need to also show here, right? Okay, so what will come here f1? So see the differences are this, right? These are the differences. So uh, if I take for example here the differences 1 2 1 2 differences are 1. So one frequency is 550, so second can be either more than 1 or less than 1, plus minus 1 can be. So it can be either 551 or 549, correct? Again 3. So I think all these will be having same possibilities with 1 because one frequency you know already. So these 3 can be either greater than 1 or less than 1, differences are there. Okay. Similarly, all those things possibilities are there. Similarly, difference can be 2, difference can be 3, difference can be all these. So let us write the various possibilities of 2. Okay. What we can do, let us write for various possibilities of 2. This I will remove. Options are given. Uh, Five, you no worksheet you can check now. First worksheet in longitudinal wave. First worksheet question number 27. Okay, 552, 553, 560, 557, 578, 560, 552, 553, 558, 551, 553, 558. How do you do that? So if I consider like this, the difference of 1 plus minus you have to do. So add 1, subtract 1. So 551 can be possible. Subtract 1 and 549 is possible. Right? Similarly, add 2, subtract 2. Correct? How much it can be? So add 2, subtract 2. So 552 and 548. Similarly, add 3, subtract 3. 553, 547. 5 you add 550 and subtract 5, so 545. Then 7 you add 557, then subtract 7, so 543. Add 8, 558 and subtract 8, so 542. These are possibilities for all these 2 3 4. 2 3 4 can have these possibilities. What about this combination? You cannot tell about this, right? We cannot tell about this. So for this definitely we can, if with the combination with 1 is happening, then these are possibilities. Hmm? And if you go 2 3 2 4, then among themselves you have to choose which will be more complex. But now let us check the options. What are options possible? 552, 553, 560. Okay, so what are, I think another approach is to check by option. You take each of the option and try to match, and whether you are getting these differences or not, that you can also check, right? Correct. That may be easier, I think. This may be little lengthier. huh? Maybe we try that. Okay, so you try to write the options. Okay, I will write option A. Option A is given 552, 552, 553, 560. Okay, so option B. Option B is given. Okay, let us check first option 1. Is it possible or not? So one of them is 550, right? So with 550, can it show all these possibilities? 1 2 3 5 7 8. So you need to find these differences, correct? So take difference of 1 and 2. 1 and 2 will give 2. 2 is there. Okay, the 1 and this next 3 5 5 3 is also there. 550 6 is not there, right? 550 minus 560, 10 will come. Sorry, 10 difference is not there. So you reject this one, correct? We reject that. Like that, I think it is better to go with that approach. With option, you go. Otherwise, there may be many possibilities. We will not be able to figure out. Time will be waste. Huh? Then two option may be possible. We don't know. Check second option. 557, 558, and 560. So we have to check with 550. So difference of this 3 is coming. 3 is coming here, and 558 is 558 is also coming. Then 558 is coming. 10 is not coming now. 10 is not coming. 10 is not coming, so we should remove that. Why we should take 10? 10 differences are not there. Next you go for 6. C option. So 552, 553, 558, 550. So what are possible? 2 is possible from here. Then 3 is possible. 8 is possible. So we are getting 2, 3, 8, right? What about 5? 5 is possible? No. 6 is coming now. 6 is coming here. See, 5 is not coming. 6 is coming. 6 is not there. So leave this option. This is also not clear. Last option you check. 551, 553, 558. With 550 you need to check. So what are the possibilities we are getting? Check now. We are getting 1, we are getting 3, we are getting 8, we are getting 5, we are getting 2, we are getting 7. Everything is coming up. 1 2 3 5 7 8. Yes, this is the only possibilities, correct? Yes, clear. So there is no other option. You have to check each option. Okay, okay, let us go next. Let us move to exercise 2. Exercise 2, some questions we can select. Question number 5, let us try. It's a good question. A narrow tube is bent in the form of a circle of radius capital R as shown in the figure. Radius is R. Two small holes S and D. This is a hole here S and D. Okay, and made of position right angles to each other. So this is at right angles, 90 degree. Source is generated here. There is a source kept as a generated wave. Intensity is I naught. Equally divided into two parts. One part travels along longer. So this wave which is getting produced here, this wave is now traveling in this direction, and another wave coming from this. Both the two waves are coming here. Okay, equal energies they have, divided one parts longer one. Both the part meet at D where detector is there. There is a detector here. Okay, now we have to check if a maximum is formed at detector, then the magnitude of wavelength lambda we produced may be given. Suppose there is a maxima happens. So option A is condition of maxima. Maxima at A, maxima at D. Here detector is getting maximum. So what is the wavelength they are asking? They are asking maximum wavelength. Maxima is happening, find out the maximum wavelength. They have given maximum wavelength as pi r by 4. So check out whether this is possible or not. Maximum wavelength. What is the condition for maxima? Yes. Other options also I will write. Minima is formed here, then the magnitude of wavelength may be. So they are saying minima is happening at D, minima at D. So wavelength may be given as 2 pi r by 3. Okay, then what else? Option number C, maxima value of lambda to produce maxima at. So again think maxima at D, maxima at D. So maximum value of lambda is given as pi r, and maximum value of lambda to produce minima at D. So option D is minima at D, minima at D. And what is the value of wavelength? Maximum wavelength is pi r. Okay, let us try this. Question is clear, yes? Can you give an attempt? Try this. Give an attempt of this question. Also note here one thing, that both the waves are coming from same source. So definitely both the waves must be same in every respect. That means both the waves are coherent waves. So only thing is that you have to calculate path difference for maxima minima. So I'll give you the hint. Try to calculate the path difference. Path difference means distance traveled by the wave from the two paths. Take the difference of that path. Then apply the condition of maxima and minima. From that condition you should be able to solve this. Try this quickly. And there may be more than one option possible. What is the answer? Anybody got? Come on, it is not difficult. You should do it. Path difference means this path. Suppose if I take this path, one path, if I take this path is another path, what is the difference in these two paths? That is what it is. Path difference. Hmm? So tell me, this total circle is 2 pi r. This is 3/4 of this circle and this is 1/4 of this circle. So what will be path difference? Delta x. Path difference you should be able to tell. Path difference is 3/4 of 2 pi r minus 1/4 of 2 pi r. That is the path difference, right? So that means how much? Half of 2 pi r, correct? That means pi r. So path difference is pi r, and if I consider maxima, For maxima, what is the condition? Delta x must be n times lambda. So from here you got lambda is equal to pi r by n. That's all. And if you want maximum value, so if you want maximum value, so n you will take as minimum, and minimum value of n is 1. So this will be pi r. This will happen when L is 1, right? This is what it is. And similarly for minimum condition you apply. For minima you write, for minima path difference must be how much? N minus half lambda, and this must be pi r, pi r. So from here lambda will be pi r divided by n minus half. Okay. So if you want now, here what they are asking for maximum, we have got the condition. What is the condition for maximum? Pi r. So option C is correct. Option C is correct. What about minimum condition? Minimum, maximum wavelength, and this is any wavelength, means possible wavelength they are given. Maximum wavelength. So if you want this maximum minimum value, minimum means what will be minimum? Lambda max. If you want minimum means here n can be minimum is 1 minus half of 2 pi r will come. This will be happening when n is equal to minimum 1. So maximum is not 2 pi r, so this answer is not correct. Now what about any possible values? Suppose I took n as 2 I took. So 2 to 4, then it will come, right? Yes. If I take n as 2 in this formula, n as 2, then lambda can come as 2 pi r by 3. Yes, and this is a condition for minima. Minima will happen at many other condition, but this is one of the condition where n is equal to 2. So they are saying that this is possible. Minima is possible. Yes, it is possible. So we have two options, option B and option C. Are you clear about this? Yes, tell me. So what is the problem you are facing? Why are you not able to take attempt, or what is the confusion? Tell me. Phase path, what is the there is nothing now. Path difference formula direct is n lambda for maxima and minus half lambda for minima. Phase difference is 2n pi for maxima and 2n minus 1 pi for minima. You have not practiced questions, right? You need to practice problems, then only you will get to know like what are the formulas. You need to work out. That's why I've given these worksheets. What? Yeah, lot of problems will be there. Lot are there, well, that's why you have to practice everything now. If you can solve all these questions, then only your base will become strong. Easy question anyway, you can do it. That's what they are doing in the schools. But for competitive exam, you need to go little bit different type of problems. You have to go for little bit difficult, means J level questions. You know, now your senior he has done very good performance in J NEET student. Huh? How he did it? Because he was solving J questions only, and definitely we are sure that he will be scoring very good marks in NEET exam. Definitely. If he can score 96 out of 100 in JEE, then NEET he will definitely he can score 100 percentage. 100 percentage he can score 180 out of 180, because that person is always working out problems and asking teachers. Whenever we are there, he comes and asks questions. Always he is asking questions, doubts. Like that only you have to be. Since from early, means from grade 11 in itself, he was very serious. He was also topper, I think, in grade 10th, right? It's not difficult. See, you need to work out problems and you need to come out uh, to discuss problem. What is the doubts you are facing? So that is not a very difficult question, but only thing is you have to apply condition, maxima minima conditions. Okay, let's move next. Worksheet 3, let us go to worksheet 3. I think worksheet 3 is subjective question. Subjective question it is, okay. Maybe it is tougher or difficult level, but okay, we can try that. Question number 23, let us take. Question number 23. A sonometer wire under tension of 64 Newton is vibrating in its fundamental mode. Sonometer wire is there and it is vibrating in fundamental mode. So its frequency will be, both sides nodes are there. So 1 into V by 2L, right? And they have given that tension is given, tension in this string is 64 Newton. Okay. Fundamental mode. Length of the wire, length L is given as 10 centimeter. Okay. Mass is given, mass of wire is 1 gram. 1 gram. Tuning fork has same frequency that of a wire. So there is a tuning fork and this tuning fork has frequency same as this F, fundamental frequency. Vibrating fork is moved away. Again, this is a beat related, this Doppler effect related question. Lot of Doppler effect related questions are there. Leave it. Doppler effect is not at all. They should not have removed Doppler effect. Doppler effect is such an important topic. Why they have removed Doppler effect? Huh? J also not there, Doppler effect. Advanced it is there. Okay, now similar question I am giving, you should be able to solve this. Question number 20, solve it. Okay. There is a source here and there is a person or observer here, listener. So this distance they have given as 2 meters and this distance is 0.75 meters. Figure shows a tube in which sound is fed at one end and receiver. The frequency of sound can be varied. So frequency of sound can vary from 1000 Hz to 2000 Hz. So this frequency of this source is a variable. Find all frequency for which a maximum is detected at the other end. So here you are getting a maxima. maxima. So you need to find this frequency for which he will get maxima. Speed of sound is given. Sound speed is 350 meter per second. Now you should be able to solve this. Yes, both of you try this. And remember, this answer of frequency must lie between this, because this is the range of frequency it can produce. Yes, any answer? How much? Delta x. Apply the condition na maxima. No, what is the answer? Come on. Because this is 0.75, this is 2, this is 0.75. So this distance is definitely 2, and this is 0.75 plus 0.75. So 0.75 plus 0.75 is extra distance, correct? Because if you want to calculate path difference, you calculate. This is 2 plus 0.75 plus 0.75. This is first path minus second path, which is 2 only. Because it is straight, it is coming like this. okay, which is 2 only. So that difference is nothing but 1.5, that is correct. Then you apply the condition for maxima n lambda. So this n lambda is 1.5, lambda is 1.5 by n, and this lambda must lie between this. So apply that condition. This lambda must lie between this. So what you can do, apply that condition. Lambda must lie between 1000 to 2000. Okay, between this. Can it be equal also? Equality condition are given in the question or not? Between they have given. Between means we can leave that, equality you don't take. Now here lambda substitute 1.5 by n must be between 1000 and 2000. Okay. So what are the possible values of n? Suppose I choose this condition. You can choose either left side condition, right side. Suppose if I choose left side condition, then n will come this side. It will become 1.5 by 1000. Okay. No. This is not the condition lambda. Lambda condition not frequency condition. It is frequency condition. It is. So lambda is this. What is frequency then? Frequency is speed by lambda. Correct. So speed by lambda you do know. Speed is 350. 350 divided by this 1.5 by n will come here. So how much it comes? Frequency comes how much? Solve out. 3500 by 15. 3500 by 15 times n. How much this comes? Can we cancel out this? 15 5 it will get cancelled. 5 into 3, 5 into 700 by 3. 700 n by 3 it is coming. Now we'll apply the condition. So frequency must lie between 1000 and 2000. Apply that. So 700 n by 3 must lie between 2000 and 1000. Okay. So what will be n then? N you calculate. N you calculate. Two zeros will get cancelled. So n will come and 3 will multiply and divide by 7. So this become 30 by 7 and it will become 3 into 20, 60 by 7. So that translates to n must lie between, it's an integer, okay, note that 30 by 7 is what? 7 4 point something will be there, correct? 28, nearly 4.3 you can take, and this you can take as 7 8 56, 56 40 will come, nearly 7 7 40, 8 point, nearly approximately, and it is a integer. So integer means greater than 4.3, the next integer will be 5, okay, 5, and less than 8.7 means 8 we can take. So you can say that n must lie, equality you can take now, it is 5 and 8. Yes, correct. And that's all. Now you substitute here, because they are asking what are the possible values of frequency. That means 5 6 7 8 you have to substitute there. So frequencies can be equal to 700 by 3 multiply with 5, 700 by 3 multiply with 6. You calculate those values. 700 by 3 multiply with 6, 700 by 3 multiply with 7. 700 by 3 multiply with 8. These are the possible values of frequencies for which it will come. Check the answer. What are the answers given? 20. Check out. Let's calculate for the first frequency, this one. How much it will come? 3500 by 3. How much? What will be that frequency? 3 1 3 1 20 3 6 15, nearly 11.1167 you can take. Yes, this is correct answer. Next frequency will be what? 700 by 3, that 2 will get, so 1400 will come, correct? 1400. Next, 700 by 3 into 7, so 4900 by 3. 4900 by 3 is how much? 3136, nearly 1633. Yes. Last one, this becomes how much? 5600 by 3. So 31 26, 38 24 20, so 6 7 you can take, correct? Yes, this is the answer. Are you clear about this? Yes. Any doubt? Kavin, Chatresh? Done. Then you can work out question. I hope your doubts are getting clear and you are supposed to work out this exercise. I will be sending you exercise like this, 2 or 3 exercise. Basically each chapter has 3 worksheets. So after we finish that, I will give you, you must work out this. Then this Sunday I will conduct test on this chapter, waves, complete chapter. Okay, right? Then you write, then we'll see next, then Monday onwards we can start one new chapter, or once your syllabus is over. Yeah, yes, Kavin. Next class Monday. Next day after tomorrow, alternative we are taking, right? We'll keep that. Hmm. Hmm.